Okay, so today we're gonna do IoT attacks, right? We're gonna try our best to simulate the network environment. I put a little bit of thought into how I wanted to do it. So we're gonna use Raspberry Pi today. Unfortunately, our wireless routers is not connecting to the internet, so you won't get a lot of like the services because IoT is really about pulling data and using the data, right? I was gonna do web scraping with it. I test successfully at home, but in here we can't connect to the wireless network with our wireless router because it becomes a rogue device and that's a big no-no. I did lower the security settings on the router. But first we'll talk about how to approach IoT attacks, and Internet of Things is very common in supply chain and manufacturing environment. So we want to really address this area because it is a highly demanded area for cybersecurity. So Internet of Things are just your endpoints, your smart devices. It could be a wearable device like a watch. It could also be healthcare kind of device. So a lot of the hospitals, they use this to monitor heart for patients, and also other things, right? Vital signs, etc. So with that, we need to understand how to secure them better and be able to assess them for improvement in security. The fall down tends to be the firmware. So a lot of the times we see that most IoT devices lack security measure because it's using outdated firmware. Now, you would see IoT devices that come in many different flavor. A lot of them are embedded systems. So embedded system would have some kind of interface, not always with operating system, but the majority of the time they would have something like embedded Linux. And with that, you would see some menu options, maybe buttons or touchscreen type of buttons, so that way they can activate the device. So some devices are fully automated. So when you plug it in, it's ready to go like Alexa. Other devices, you will have to do some configuration and be able to utilize it with its full features. So what we see is that there are a lot of poor design in how security would be in the context of security. So they are vulnerable to attacks. So in the first question, it asks you, why are IoT devices prone to cyber attacks? Mostly because they lack security measure, as you see in the notes. A lot of the times they don't have updates with firmware or with the software. And some of them are so customized that, the software doesn't always have the security patches. And then you would see some poor design, and poor design could also be in the hardware base, along with software base, right? So that means that they are more prone to attacks because they are easier as targets. Now, when you use Shodan is the browser where we can find a lot of Internet of Things that are interconnected in the larger, like a worldwide aspect, right? So autonomous system, IoT devices, the Shodan is the browser that we often use to detect different type of device that are connected worldwide. So that means that someone can find our devices if we don't secure it. So all your IoT devices use your computer design that was created in the 1940s, right? So what you see is von Neumann model in computer science has always been integrated in almost all our smart systems. That means that a computer would have a processor or a processing unit. And depending on the architecture, most of your IoT devices use ARN, right? Which is what you see for Android-based system if you're looking at Android smartphones or Android watches and so on. So the processor can be vast, right? Motorola use a different architecture compared to IBM or Intel or, etc. So Apple uses a different type of processor. And ultimately, the hardware design is different and the instruction sets are different. So at a higher level, what we see is that these processors would execute the same thing. It would process tasks based on instructions that are created by programs. So that means that we would be able to determine, right, the activities of the system by looking at higher and lower level instructions from the processor standpoint. All computing system would have some kind of storage. Hello. And some system would have permanent storage and memory, but as required, they need to have memory for processing certain tasks. So in order for the processor to execute the task is queued and it needs to be stored somewhere, and the instruction sets need to be stored somewhere. Some of it is on the processor, but a lot of it is on memory, like RAM. And in some cases, you would see EEPROM, those are flash-based memory. So a lot of the times, unlike your regular desktop or laptop, you would see ROM-based or programmable ROM-based type of storage. Hello. That means that flash technology is highly integrated with IoTs only because some things are permanent and something can be programmable. So take an example of a wireless printer. That's an IoT device, right? It's connected to your wireless network. You can tell it to print out documents or you can scan documents and be able to have that input into your system. So the printer uses EEPROM and flash technology. It has a storage where all the queue print goes into that storage, and it's looking at the storage to determine which print is going to be executed first. So it's really important that we think about how RAM is used or how memory is used on these systems. And then you have firmware, right? Firmware is a way that we can utilize instructions to make sure that the hardware is executing the task that it needs to be. For example, on your smartphone, if the application requires a microphone to be activated so you can have voice command while you're driving, that's part of the firmware mechanism. Or when you're using a web app to be able to pay with credit card and it activates your camera to scan your credit card or take a picture so that way it can simulate the product in the room, that's part of the firmware package. The problem with this is sometimes firmware is outdated for that component and it's vulnerable to attack, right? So, and then what makes an IoT device is data exchange services. That means that it needs to have internet connection to be able to either obtain data or send data. So in an automated system, like your thermostat or Ring, the doorbell, right? Those type of devices have exchange information. Someone's at the door, it activates that signal, it notifies you on the app. So that information is being exchanged across multiple systems and through the internet or through the network connection. So the interfaces are really important. As an attacker or a pen tester, you have to really think about your interfaces, especially when you deal with IoT device. So there are physical interfaces where you can actually touch and open the device. Some devices have enclosure and they're sealed and you cannot open and access the internal. And then we think about network interface, how it's communicating with cables or through the air, wirelessly or through an Ethernet adapter. Or it could be another form like fiber optic. And also the interface on how the human interact with the device. So when you're looking at things like Alexa doesn't really have a screen. Alexa is just a speaker that has a microphone built in. So when you call its name, right, it's instructed to respond based on that particular voice command. So then, or even when you're using Google, right? So that's a human interface, and you would think about, like, because IoT is vast. You would see a lot of different type of interfaces. So attacking IoT or pen testing IoT is not an easy task because it's such a huge diversity in how we use these components. It's really, so when you are targeting a certain IoT device, you really have to take a look at the components, how it's built, and how you're interacting with the device. That's really important. Because without that, you cannot plan out what you would use, right? Okay, so in the notes, I try to give you all the details of all the components. And I pull this from OWASP. They have a research base specifically from IoT from, years ago up until now, okay? Now, there are different various brand and manufacturer, and there are other things. So we have to think about the design of the components, how the components are used for the IoT itself. The majority of the times now you would see them being used wirelessly, right? Bluetooth, BLE, Wi-Fi, Zigbee. Drone also falls into this area, and drone has a little bit different set of interfaces. But then we, depending on the model of the drone, the type of the drone, military drones different than personal use drone, etc. Okay. And then, if you're looking at the tablet or even a smartwatch, you would have touch display for the human interaction and then wireless connection. So the majority of the time, your IoT device is going to have multiple interfaces that's incorporated for its functionality. Okay. So I borrowed this also from OWASP. So this kind of gives you an overall diagram of how a basic IoT device is designed and how the ecosystem supports the components of the device. Okay, so with that, we would lead into the type of attacks. So very similar to wireless devices, because they are wireless, you are going to see similar attacks. And because they are computing system, you're going to see similar attacks, right? The majority of the time, attacks really play on, vulnerabilities. That's basically it. If you focus on the vulnerability of the device, it really flesh out the type of attack that the systems is going to be subjected to. So in communication, when we look at the 3A, attacker intercepting communication between the smart health monitoring system and the hospital server to exfiltrate sensitive health data of the patients. So when they're intercepting, that's man in the middle. So this form of attack is usually coupled or added to other attacks, as we learned before. So part of finding information or doing footprinting is to be able to intercept or be able to modify packets and things so you can do exfiltration. So man-in-the-middle attack is often seen with other type of attacks for IoT. And this happens quite frequently for healthcare. Now, an attacker, in order to take down many devices in the wireless segment, they can deplete the bandwidth by subjecting the router or access point to a lot of requests, or even the server, if we have server connecting to that, right? Or web services type of system that is IoT based. So sometimes you would see denial of service attack. Simply that just sending a lot of requests so that way it will floor the bandwidth. And taking away the bandwidth, it would remove, or the system would no longer have the resource to communicate or exchange data. So that's another approach that they would use to omit the systems. Then C, this is also common in our regular computer system, but exploiting unpatched vulnerabilities from day 0, the first day, is called a zero-day attack. And a lot of it comes back to software and firmware. So if the system is designed poorly on both ends, you would see that zero-day attack is being used. So if I know that a certain organization deploy a bunch of these devices, I would then research them and prepare for the zero-day attack. So simply, zero-day attack is a way to exploit codes and the flaws in the codes. And then in 2023, and this is a real case, a hidden backdoor was installed in the firmware of Taiwan-based motherboard manufacturer Gigabyte that allowed hijacking and installation of malicious code. And that's firmware manipulation. So if you have Gigabyte motherboard, well, you make sure that you find firmware information and update it. So we see a lot of the systems that are manufactured by different companies that, you know, sends out data to other entity, right? They sell or they take private data information. So that's a way that to exfiltrate data is through firmware manipulation. Like activate your microphone and listen in on all your voice conversation and be able to extract certain words from your voice conversation and send that out, right? We didn't authorize that, but it happens. That is done in a lot of TVs. It still happens. Any question? So attacking IoT is slightly different than your regular attack because your attack surface needs to be carefully designed or evaluated, I should say. We know that IoT devices have limited hardware, like their processor might not be as fast as your desktop processor or your laptop processor. Hardware components is also less RAM or less memory. Most IoT devices are pretty simple. They are designed to do specific things, right? If you're looking at Alexa, respond to your voice command, search the internet to be able to give you some information or execute certain tasks like your playlist. So that means that their software is also limited to the functionality of that IoT device. And a lot of it, we see that the processing power is less. You might not have 12 core, right? Running at almost 5 gigahertz. No, right? We would probably see that wireless communication is often at 2.4 gigahertz, rarely at 5G. Some devices are equipped with 5G. Processing power is going to be a fraction of what you see in your regular Intel processor or AMD processor. Maybe at like 2 gigahertz or 2.8 gigahertz and so on. So a half. So with that, we know that there are security features that were not included. Because if we have limited resources for the system, you have to make a choice, right? The functionality of the system might require a lot of memory or processing, and that's mostly used for that. So to run additional services in the back for security, sometimes that will require more resources. So they often omit that. So that's a decision of the developer and the engineers. So that means that your attack surface is greater with Internet of Things. Do you have any questions? So that we're going to come back to how are we going to address bring your own devices to work. A lot of workplaces now are very flexible about this, right? But you do bring your own device to work at your own risk. So if they have open networks, your devices might be subjected to malware, and that's another form of attack, right? if you're not careful, because the internet is is a vast amount of different things that you can access. So it's really to the user. But because we have so many different devices in an organization, when we're looking at the policy, if we accept all of those devices, we have to find a way to standardize our rules. So sometimes that can be very complex. So for example, if I'm only allowing iOS and Android smartphones to be used in my network, that's simple. But in an environment where you would have other things, right, other systems that are connected and interconnected, what you would see is that you would have to keep customizing your security measures to make sure that you protect those systems and your infrastructure. So what happened is they would simplify and standardize for the majority of the devices that need to be protected, like smartphones. And they would leave out some of the very more unique devices, or they don't have the set of rules for those. So those devices then become vulnerable to attacks. So you see this in more of like the larger manufacturing environment, instead of even bring your own devices, even the company supply the devices. But if you have so many devices, that can be a little bit more challenging for IT to streamline and standardize the rules. So that's usually the fall down for the network with IoT devices. Can you segment the network and put all the IoT devices on there? But yeah, but then that becomes a single area for target, right? So either way, you have to really weigh the risk in one area and accept some of the risk in other area in order to implement IoTs. You have any question? So I encourage you to really flourish in this area, because IoTs are here to stay. They're not going away. Everything is going to be cloud-based. So, this is a very much needed area in cybersecurity, right? A lot of professionals are mostly protecting the network or pen testing. But when we're pen testing, even in some areas, this is a niche. So do well with this, and you can just find old stuff, plug it in, see if you can, reverse engineer it. And if you look at OWASP, OWASP, they have instruction on how to reverse engineer some of the standard ones. And there are resources and tutorials available online abundantly. Okay, so attack, eavesdropping, listening on another conversation. There's malware attack. That's also very common. You know that also the design for IoT is power saving, and power saving require constant, system status update. So that way it would check like when the system goes into certain hyper mode, and then when the system is activated. So that means that the feature that's implemented IoT sometimes takes away security features. Okay, so the vulnerabilities. These are the common vulnerabilities for IoT, and it's also very similar to endpoint security, right? Because they are endpoint security. So for question 6, is to explain why attacks of IoT devices have greater impact in the healthcare industry. Because the attacks for IoT healthcare device can cause malfunctioning and result in physical consequences for patient life. So if you're looking at IoT devices that are used for monitoring patients' health or vital type of systems, right? If those device becomes malfunctioning, it will impact people's lives. So physically, there is a greater impact with IoT compared to other systems. So they are critically important. So when you're looking at healthcare industry or their infrastructure, right? Identify those type of system and their functionality and their design and their flaws are probably, higher up on the list compared to, your endpoint system or your other endpoint system. They are all important, but, we have to really think about like, will that jeopardize a human life? And if so, right, we want to close out the security gap on those so that way it doesn't happen. And companies will continue to use devices until they can no longer be used, right? Because if they're functional, why implement new ones? Because implementation costs and it's also can create disruption in the business. So legacy just means older. And when a manufacturer stop producing certain components, they stop supporting the patches, the updates, or even the hardware replacement on those devices. So when we don't receive security software updates or patches, even the OS on those devices, they become more vulnerable to attacks, right? So the higher the weakness, the more vulnerable those devices are for attacks. So the lack of is what we will look at. So as a rule, we really don't use anything that stopped being supported, operating system, applications and so on. So if the company continue to support, you would still continue to get updates and things for the software as, they might look at some areas and by regulation, they have to be able to maintain that. But if the company goes out of business or they stop making those devices, that will be the right time to retire the device. Because if you continue to support those, right, they might be the problem in your network. I've read several cases when I was trying to build out your notes about how people forget these legacy devices that are still being connected, but they're like low use. And then attackers would then capitalize on, that's a way to enter some part of the network. And then be able to utilize those devices to get to other areas. Any questions? So your book gave you some examples if you have access to the Kindle version, which is free, which is cool. There are great information online. There are a lot of different cases and also information from security company about how to better protect IoT device from a personal and company standpoint. So we don't want to use legacy device or older devices that are no longer being supported. So let me move this down so that way we can see all together. So the majority of the device access, I talked to my 41A class the other day about doing forensic on smartphones and things like that, right? It is a smart device, so likely that you will have to start with brute forcing to actually access the device. So the vulnerabilities start with weak password, right? Fewer characters, simple, plain, dictionary-based type of password. It will be subjected to dictionary attack, brute force attack, pass the hash, or rainbow table attack. So anything in the horizon of password cracking, we would see that. That's how an attacker can actually access the device interface, right? Now, some IoT devices would use key-based type of authentication or communication. So with that, we would see more encryption being implemented, but also depending on the type of encryption and then the version of the services. So if we're looking at SSH secure shell, which version is it being used? And then are they using password based or key based type of of SSH? All your IoT devices are usually connected to some kind of cloud storage, right? Syncing your data, like your smartphone is doing that for Apple and Google, or, you know, if you have Microsoft phone, which went out a long time ago, but one way or another, right? We would see that there's storage being used because the devices are made with less internal storage. And then if you want more internal storage, you're going to have to pay for more internal storage. So a way that we can save hardware resource is to utilize cloud storage. That's just a container elsewhere. So if you use unsecured cloud storage, you will be subjected to confidentiality, right, and private data leak. So they can exfiltrate or obtain your data. So we should do better with multi-factor authentication and turning off the services that we don't need. Like cloud, you don't have to leave cloud on all the time, right? You're not syncing all the time. Ideally, yes, you should sync so you don't lose your data, but you can also turn things on and off, right? So I think a lot of it is really our decision in how the system should be used. So for an organization that uses IoT that communicates with the cloud all the time, like healthcare, what we want to do is we want to protect that container, and the communication between your device and the cloud storage should always be encrypted, right? Even using symmetric key-based type of encryption or stream-based encryption, right? And then we talked about outdated software and firmware, so they can change the firmware, inject code into firmware codes to make it execute or activate certain things, because already your firmware is instructing your hardware to do something. So modifying some of the firmware instruction can be easily done if they have access to that. Or they can install backdoor, or they can do denial of service attack or a 0-day attack. Then you got devices that are on network connections that's not secure, like open network, open wireless. They can take over the device by doing remote control. And I'm hoping that part is successful for you guys today, so you can remote control the Raspberry Pi. They can impersonate the device by spoofing, right, MAC and IP. And all of that is just modifying the ARP table overall. Or doing man-in-the-middle attack or eavesdropping. Lack of encryption, someone can pull data, someone can take control, because encryption can be communication-based encryption or data encryption, right? Or impersonate the system and then doing man-in-the-middle. I tried to leave out like man in the browser and all the other stuff because we don't want to kind of branch off and talk about like web application, but all of these devices, you know that it's accessing some kind of web services. So that can also happen to other form of attack, like replay and other things can happen. So it really depends on the functionality of the IoT. And then physical tampering. So if all else fail, right, I'm just going to try to like unplug it or destroy it. Simply that. So you see industrial devices, if they can't attack it logically, then they would try to go cut the power cord, right? Done. Sometimes malware installation would cause disruption, obtain data, and then do firmware manipulation. So some of that is also pertaining to physical tampering. So that means that if we're using IoT devices, you gotta make sure that it's also physically secured, right? A lot of the times they would put it in an enclosure, they make sure it's locked. People don't normally have access to that, out of sight, out of mind. So normally you don't see them being at eye level or arm reach, stuff like that. Like just, a lot of the common sense that we have to apply to how we physically secure these things, because we can't really lock them away, right? It might need to be on the floor, or, especially at the hospital. So we want to make sure that, someone walk by, enter the room, they can't just grab it, disconnect it and go. So we have to kind of bolt it down or put it on some kind of more heavy equipment so that way it doesn't just grow leg and walk out, right? So in the next part, it talk about signs of system being attacked. So these, I thought it was kind of interesting, so I included these so that way you kind of see, because sometimes you have people questioning, like, what's wrong with my system or what's wrong with my device. So you can see some abnormal behavior, surges in network traffic or data use, and then resetting password type of message, account activities that is irregular. A lot of times it's also is sluggish in the network and also performance space for the local system. So the common signs, I try to summarize that for compromised IoT device, unusual activity or processes. That could also be malware related too, right? But that's compromised as well. High data or bandwidth usage, unresponsiveness, unknown request messages, and unusual account activities. So if the device is being remote controlled, the user would complain that it's not responsive to their touch or their command, right? Because now it's under someone else's control. And then if, there's a Trojan installed, then it will constantly send out any kind of keystroke or any kind of data communication, or anything that's obtained in that device would then be extracted and sent elsewhere. But on personal devices level, if someone is getting a text message about password reset and they didn't reset the password, right? Now, most company, they would have a way for you to report it, so they can lock that account and so on. But I think, for the majority of the part, they did mention a lot of stuff about phishing, but phishing on IoT devices can also be, but phishing would need your assistance to be able to give away some information, right? So that also happens on smart devices as well. I think health bands like Fitbit was subjected to a lot of different type of attacks in the past, and they are doing a little bit better because it constantly take your vital information and then it updates it through the app. And if the app has flaws and their server has flaws, then your data would then can be exfiltrated, you know, so. So the practice, how we can reduce the vulnerability, use strong passwords. Multi-factor authentication is important. So password reliant, we want to do away with just that. And then if it's numerical based type of authentication, right, that can be brute force or enumerated very quickly. So use stronger passwords. Use multi-factor authentication, something you have, something you are, something you know, somewhere you are, etc. run updates. So when, when the devices are due for software updates, update the device. And in a manufacturing environment, sometimes that can be challenging because your system have to be constantly working, but then you need to have backup system to take its place while it's being updated. And then, so we will need to swap them out for updates purposes. So app permissions is so important. I think that it's good to do a good overall inventory of your apps, uninstall the apps that you don't need. And then the permissions for the apps, we have to really ask ourselves, like, do we really need this? I think now most of the smart devices, you can allow it for one use or you can continuously allowing it, right? So we have to really think about how that permission can affect the overall vulnerability of the device. Should the microphone be on all the time, or is it only on when you use it? And then if you're wirelessly connected, even on a secure network, you should consider using VPN. Right, VPN, it's a way that we can utilize encrypted based traffic. So that way it's not visible. So eavesdropping is a little harder, right? So we're buying a little bit more time with VPN. And there are different VPN technologies. So in an enterprise environment, you would set up RRAS, right? Remote access server. And with that, we can set up like IPsec or, some kind of encrypted technology for the communication. And we can control who's on it. And I didn't include it in this, but in an enterprise environment, in a network environment, you should also have things like, intrusion detection system, intrusion prevention system, and firewall is critical because if your endpoints is being jeopardized, it should detect that, right? If it's being targeted, it's going to come across the network and you should be able to see that. It just, locally, it can't just appear on its own, right? A form of attack cannot just target a device without crossing the network unless they're using near field communication or something very direct. But if it's through the network, your appliances or your security should be able to contain it. If there are rules in place, of course. So the last part of this, I kind of want to focus on a model that the industry is recommending. It's a little bit different than your regular approach for pen testing. So when we pen test, we use threat risk modeling. We identify the threat, we prioritize the threat. We would try to omit or remove the threat, right? Contain, eradicate, and so on. So that's a threat and risk modeling. So with that, what we see is when we're using that direction or that model, it really focused on the design, which is difficult for Internet of Things because the design for Internet of Things are there are a lot. You have many different designs, many different architecture, many different functionality on the Internet of Things. So creating a model, a standardized model for that can be challenging because it's not all the same. It would work with your network systems and, your infrastructure for most part, like your servers and so on, but it would not work with IoT for most part. So threat risk modeling would require pen testing of IoT devices, and you would then have to categorize all different ones, which architecture, the type of design, the model. There would be thousands and millions, and it would be endless. So it wastes too much time. It would take too much time. Okay, and more resources. Any question? Okay. Okay, so the model that they suggest to use is called the attacker model. And so we would need to start out with identifying the type of physical access based on what type of device that you're working with. So as I mentioned earlier, the physical access could be physically touching and opening these devices. So when the attacker opens the enclosure of the IoT devices, like pry it open or unscrew or be able to see the internal components, that's called invasive access. The reason why someone would try to do invasive access is to look at how it's designed, the components that's made for those devices. They can also use this information to do reverse engineering of the device. Now, if I'm not able to open the device, I can still have a non-invasive access in which I would locate the device, but I won't be able to touch or open it, right? So if the device is locked in a box, but I know that that device is there and it's connecting to the larger network, then once I locate it physically, I can find ways to, if I want to cause the damage, then I can think about, oh, well, how can I destroy this device, right? Logically or physically. So that's called non-invasive access. And let's say that today, when you're connecting to your target system through the wireless network, right, because it's open network, then that's considered local access. So you are locally accessing it through a segment of the network or the greater network. And then if you're able to control it from another region or another country, that's called remote access. That's pretty simple, straightforward. So when you hear cases like the attacker turning on people's camera, right? That's remote access, remote control, right? Or someone controlling someone's Tesla. Now, or someone's controlling someone's Tesla in the parking lot. That means that they're sitting in another car and controlling that Tesla. That is a non-invasive access, right? So you see the approach is a little bit different for different things. Okay, almost done. Any question? So Normally we harp about, let's put it on a virtual LAN, set up a different subnet, isolate the network, call it a day, right? In most of our systems in the network environment, that reduces some of the security gap. It slows down the attack a little bit because it's just harder for them to go through some of the routes. But for IoT devices, it's a little bit different. So for 13, it says, why are subnetting, network segmentation, and port control ineffective for securing IoT devices? Because they often operate outside of that security zone. And they require different authorization access. And I'm going to give you an example. There are devices that are used and they need to be, they are functional for manufacturing purposes, and a lot of the times they have access at the greatest level. Okay, full control, manufacturer type of access. Okay, or developer type of access. So, and they would need to constantly communicate with data center, server systems, databases, things like that, where even if we isolate them in one area, it won't work because they have access in many different areas, right? So what happened is you can't just throw them in one segment of the network with all the system that they access, because you can't, because the system they access are in different part of your network. So this is why security zoning for IoT sometimes can be very challenging, like drones. And you see technology or software that are used specifically for IoT security. They sell a lot of those solutions, right? It just dive a little deeper in how the configuration, so it verify a lot of these things, and then checking for a lot of the components that we talked about. So what kind of access level would allow privileges for debugging, examining source code, root level? That's your manufacturer level access. That's the highest. That's like your system admin level. So we would see root level in that. That means that, in this level of access, they can execute anything, install anything, modify your firmware. And if your system is using this level of access, then they just have to compromise the system to execute anything. So we have to really, so in order to change the access control in this area, we really have to see that system on how its role equivalent to all the other system that it's communicating with, right? If it's exchanging data, is it read and writing the data? Is it sending the data? Is it receiving the data? Like, so you have to really map out all the sub processes to the level of access. So, and we can't just go with the role base. We need to take a look at like, you know, should we go with something that is discretional, something that, so it depends on the functionality of the system. So this is why IoT is challenging. It's just tedious. I think it's just consume a little bit more time to manage it. However, it can be done. So that means that we need to map the components, like I said before, right? How is the communication? What is being exchanged? What kind of data? Does it read? Does it write? Does it store? So you need to map the components to the authorization access level, so that way it is very clear and specific, so we can give it what it needs, but not take away its functionality. So we need to have specific authorization and permission for individual component, like how it's interfacing for communication, how it's interfacing with the human, how it's interfacing with other systems. So we have to evaluate the permission for that, for the each individual component of the device at the higher level of access. And this is the downfall sometimes. Because it requires a higher level access, then we tend to run into problems. And that is the end, my friend.